Okay, shall we get started? Oh, good morning, everybody. Thank you very much for coming today. My name is Ji-hoon Lee, and I'm from Samsung Electronics. Well, today I'm here to talk about the input service framework of Tizen platform. And this year, I just found so many sessions here in Tizen Developer Conference. They are introducing and explaining those kind of native APIs and web APIs, how you can write your application by using them. But in this session, I'm not going to talk about those kind of specific APIs that you can directly use in your application. Well, instead, we are going to have a look at the very lower part of the platform, which is called the core layer. And we're going to just find out how those kind of input-related events are just handled and in the platform side, and what kind of input-related services and functionalities, features do we provide in core layer. So this session is more like a deep dive into the platform internals rather than the step-by-step tutorial for developing applications. So, okay, here's the contents. First, I'm going to just introduce our input service framework briefly, and then we're going to have a look at the overall architecture and some of the event flows, what really just happens inside the platform on each input-related events. And then we're going to just learn some of the ways how we can just utilize our input service framework in Tizen platform. Okay, introduction. So what is input service framework? Input service framework is a framework that provides text input-related services, and it just plays two major roles. The first one is multilingual text input support, and second one is text input support for devices that does not have hardware, physical keyboards such as Bluetooth keyboard or USB keyboards. Quite simple. But before going any further, let's just have a look at the multilingual text input support first. Talk about those a little bit more because there are some of the concepts that we just have to understand when we just talk about the input service framework. Okay, here's the multilingual text input. And some languages, such as CJK languages, Chinese, Japanese, Korean languages, are known to have very complex logic for processing text. I mean, when composing characters, yeah. So to support multilingual text input support for those languages, the following support is needed: the predicate strings and comment strings and candidate window. We're going to just have a look. We're going to just identify those kind of concepts with the actual example, typing in the sentence "Thank you very much" in Japanese language. Well, at the bottom you can see the actual example. Here on the first figure there is a editable widget, and if I just type the sentence "Thank you very much" in Japanese, then the whole string will be displayed. But one thing you should just notice here is that the whole string is underlined, meaning that it is a pre-edit text, pre-edit string. So pre-edit string is a string that has not been fixed, and that can be converted to or just replaced with any other strings. So, and in this case, if you just press the space button, space key, then on the third figure, you can see there is some part of the pre-edit string is highlighted, and it just means that it is the current conversion target. And a separate window will be just displayed right below the pre-edit string, showing some of the possible conversions for the current conversion target. So if I just select one of those items, the current conversion target string will be just replaced with the string that you have just selected. And if I press the Enter key in this case, then the whole pre-edit string will be just erased, and the final conversion result will be just appended to the editable widget where the cursor is. So the appended text, we just call it a commit string. Okay, so we just have learned the concept of pre-edit string and comment strings and candidate windows. So let's go on with the basics. Our input service framework is based on open source SCIM 1.4.7, and it just explains a lot of things. If you're really just familiar with the SCIM framework already. So SCIM stands for the Smart Common Input Method. And some of the characteristics of SCIM is listed below. It has client-server architecture and dynamically loadable plugin module support. And it also provides a powerful and simple and powerful programming interface. And it is also, it has been widely used in many Linux distributions such as Ubuntu or Fedora, so you can just consider the framework, the project itself is really, really stable and fully functional. But even so, SCIM itself has been developed mainly for desktop systems, so we just have added some of the support for mobile devices that does not have any kind of hardware keyboard. So we just added some of the application side interface and the software keyboard engine side interfaces so that those two modules can interact with each other. And when I say software keyboard engine, that refers to any kind of software component that just works as a text input source other than hardware keyboard engine. Well, so that could be a actual virtual keyboard or a handwriting module or anything else. Okay, and let's just have a look at the benefits of using open source SCIM. Well, I have listed some of the characteristics of SCIM on previous page, and that those can be considered to be the benefits also. But what is the benefit of using open source SCIM? Since the SCIM project itself is an open source project, so many developers from all over the world, they have already participated in developing keyboard engines for SCIM. And so currently, SCIM supports more than 30 languages, and even in one language, there could be different keyboard layouts or different ways of typing text. We just call it an input method. So most popular keyboard input methods and keyboard layouts are already supported by the SCIM keyboard engines. So if you just download the Tizen SDK and run the emulator, there is a built-in software keyboard named Tizen keyboard, and Tizen keyboard supports more than 40 languages, including CJK languages. But if you just have a look at the source code, there is nothing like language-specific code. And what we really do in this case is that if you have a look at the example XML file listed at the bottom, the XML file itself is just internal use, so you don't really have to care about the structure or the name of the tags or attributes. But one thing I just want to show you here is that if you see the red Q there, even for Korean language, what we really do is sending a hardware key event and let the open source keyboard engine to process all those kind of character composition or just event handling or those kind of things. So that means we are just powered by the open source keyboard engines. Okay, and shall we just look at the architecture? Here is our architecture diagram. On the left side, there is you can see the application process on the left. Because Tizen supports both native application and web application, of course, native applications runs on the native framework and web application runs on the web framework. But regardless of which framework the application runs on, both frameworks sit on the top of the system-wide common layer, which common interface layer, which is called the core API layer, and the UI toolkit for the core API is EFL. So both native framework and web framework uses EFL's eCore IMF interface to interact with the input service framework that is shown on the right side. There is a big bounding box representing the boundary of the ISF. Well, ISF is a shorter term for input service framework. And you can just notice that there are three major processes, the panel process, and input service engine process, and input service manager process. Well, all those processes have their own actual names. I mean, the actual executable names, but I thought it would be just confusing for you developers here, so I just use the conceptual names, and I'm going to just introduce the actual names for all those modules on my next slides. Okay, so let's just have a look at the modules one by one per process perspective. So let's start with the application process first. As I have mentioned, the application can be either be a native application or web application. They both use the EFL's equal IMF interface to interact with service framework. But actually, the equal IMF is a set of generalized APIs for interacting with input service framework. So the actual implementation resides within the ISF-IMF context plugin module for the equal IMF interface. So we can just regard the ISF-IMF context module as a kind of bridge module or the adaptation module that connects between the application, specifically the equal IMF and the input service framework. And we have an input service manager process. Input service manager process is responsible for handling hardware key events, and when it is launched, it just loads all currently available hardware keyboard engines, and it just delivers the key event to the currently selected hardware keyboard engine. And so the hardware keyboard engine just translates those hardware key event to just compose a character based on the currently selected language. And the actual process name of the input service manager is SCIM launcher. So if you just run the ps command on your emulator after running a shell, you can just find it is running there. And we also have an input service engine process. Well, input service manager process loads the hardware keyboard engine, but input service engine process loads the software keyboard engine. So in Tizen platform, we have a strict distinction or the separation between the software keyboard engine and the hardware keyboard engine. So if anybody is just willing to develop a software keyboard engine, he or she does not really just have to care about the hardware keyboard translations because it is all done in the hardware keyboard engine side. And one thing really different from the input service manager process is that input service manager process loads all the currently available hardware keyboard engines, but input service engine process loads only one single software keyboard engine currently selected. So if the user selects another software keyboard engine in setting application, then the existing input service engine process will be terminated, and a new input service engine process will be launched, and it's going to just load the newly selected software keyboard engine. We're going to just have a look at the life cycle of the software input service engine process. I mean the software keyboard engine. After we finishing this per process view. And as I have mentioned, the software keyboard engine does not necessarily have to be an actual keyboard. It could be a handwriting module or just Wi-Fi text receiver or anything else. It just works as a text input source. Oops. Okay, the last one, we have a panel process. Panel process works as a mediator between an application and input service engine. So whenever there is a request sent to the input service engine process, the panel process receives it first and then delivers it to the input service engine process. And it just works as a UI representation module of input service framework, such as candidate window. So whenever there is a need to display a candidate window, this software keyboard engine or the hardware keyboard engine can request the panel process to display a candidate window. So in Tizen platform, we just provide a system-wide common candidate window that any hardware keyboard engine or software keyboard engine can use. And as I have promised, here's the life cycle of the software keyboard engine. Initially, the software keyboard engine is unloaded state, but when the input service engine process is launched, it just loads the currently selected software keyboard engine. Then what is the time that the input service engine process get launched? There are two cases. When the system starts, when the system boots up, the input service manager process launches the input service engine process automatically. Or if the user selects another software keyboard engine, the new input service engine process will be created, and it's going to just load the software keyboard engine. And as I have mentioned, the existing input service engine that has loaded the previous the unselected software keyboard engine will receive the exit request, and it will be terminated. And also, when a hardware keyboard is attached, that means that we are going to use the hardware keyboard for typing text. So we just send the exit request to the input service engine process and let it terminate it, because when we just type something on the hardware keyboard, the software keyboard is not needed anymore. It just occupies the screen. Okay, and once it is loaded, it could be in visible state or invisible state requested by the application. Okay, here's the event flow. What really just happens when input-related events occurs. We're going to just have a look at the hardware keyboard case first. So let's assume just you were just using a Bluetooth keyboard attached to your mobile device. So if the user presses a key, then a kernel and an X11 layer will just recognize those key event first, and the X11 server will just send the X key event to the window that currently has the focus. Then the application process will receive that event, and it can just decide whether to request the input service framework to translate that hardware key event or not. And if the focus is on the editable widget, it is obvious that we just have to ask for the input service framework to translate that event. So the editable widget will just use the equal IMF as a filter event function to deliver that event to the input service manager process. And within the input service manager process, the SCIM launcher executable will just pass that event to the currently selected hardware keyboard engine, and their hardware keyboard engine can request a panel to just display a candidate window, or just send a message back to the application to update the current printed string. And if the user selects one of the candidate items in a candidate window, the selection will be just delivered to the hardware keyboard engine, and hardware keyboard engine can then commit a string. Here, in this case, it just commits a string, or it can also update the printed string or something like that. And the application process is responsible for displaying the printed string or append the committed string into its editable widget. Okay, that was the case for the hardware keyboard, and let's have a look at the software keyboard. Similarly, if the user just touches the screen, and then the mouse event will be delivered to the software keyboard engine directly, and then the software keyboard engine will just identify which button was pressed. And then if the software keyboard engine has its own logic for composing characters, if the software keyboard engine knows the details of the language, then it can process that event by itself. It can just update the printed string, or display the candidate window as the hardware keyboard engine did. And also, you can just interact with the candidate window, just like hardware keyboard engines. But as we have seen in the case of Tizen keyboard, the software keyboard engine could be just implemented without having to know any language-specific details. So in that case, we can just make a dummy software keyboard. In in this dummy software keyboard, what it really does is that when it just receives the mouse event, it just identifies which button was pressed, and then it just sends the send key event IPC message back to the application, and the ISF IMAC context module will just, call send the event. Then it's going to just generate a fake hardware key event. So it will, from this stage, it just works as if actual hardware key event was generated. So it is the message will be just delivered to the input service manager process, and a hardware keyboard engine will just process that fake hardware key event. So in this case, the software keyboard is delegating the task for handling those kind of events to the hardware keyboard engine. Okay, then let's have a look at the how we can just utilize the input service framework. Let's have a look at the application side core APIs first. Well, as I have mentioned several times, there is a core API, and the core API provides the common interface for both native and web applications. And as you can see in the figure below, native and web frameworks have their own mappings for using core APIs. So it'll be better to just have a look at this core API to figure out what kind of common functionalities we provide in platform level than having a look at those framework-specific mappings. And also, it's not really common in your application that you use those kind of mapping classes directly. Most of the time, if you're just developing a web application, then you might be just adding a tag such as input type equals text or something like those kind of tags. And if you're just writing a native application, you'll be adding edit control in your application. And those kind of editable widgets that are provided in the framework layer, you're going to just use those kind of mapping classes in their own. But in some cases, like in native applications, if you don't really want to use those kind of framework provided edit controls, then you may create your own. In that case, you can just use those kind of mappings, the core IBM mapping classes in your application. So what can we do with the core APIs? There are some simple just functions we have. We can show and hide the software keyboard, and we can just register some of the callback functions for handling commit and create strings. And also, we can request the software keyboard engine to display a specific keyboard layouts for the user's convenience. And on the right side, there are some of the layouts that are supported in the Tizen keyboard, the built-in keyboard. And those layouts and variations are encouraged for those kind of software keyboard engine developers to support all those kind of layouts and variations, but currently it is not a must. And we can just register callback functions for controlling auto-scrolling and status changes. Whenever there is a change in the software keyboard engine, software keyboard geometry information, well, it'll be just notified. And we also have an auto capitalization feature, which is a feature that capitalizes the very first character of a sentence. So we can just set the type of the auto capitalization, and we can change the return key types, such as those are the enumerations that we just provide in currently with the support. And we can just disable or enable the return key. And let's have a look at the input service engine side core APIs. Well, downloadable software keyboard engines can be developed by using native APIs that are just mapped to core APIs. So if you just, the Tizen 2.1 was released a few days ago, and if you just download it, there is a sample template that you can just develop your own software keyboard. So the screenshot there shows the sample downloadable software keyboard, and it uses native frameworks, some of the interfaces and some of the classes. There are the mappings of the core API. So what are the core APIs do we provide in the input service engine side? We can send key events, as I have described. If we send key events, if you just call the send key event function, then it will be just work as if a hardware key was pressed. And if you just think about the case we just press the hardware key, it will just eventually accompany the release event. So whenever you just send a key event, then you'd better just send the same key with the release mask. And there are some of the masks you can just send together with your key event. Well, you can just mark it as it is the control key was pressed together, or the alt key was pressed together, or it is the release, the key was released, or something like that. There are some of the masks you can give. And there is a fourth key event. Well, fourth key event is almost exactly the same as the send key event, but for the case of send key event, it is translated by the hardware keyboard engine. But there are some cases that the key event should not be translated by the hardware keyboard engine. For example, there are some of the cases, the hardware keyboard engine that is used in Taiwan, they just regard the number keys also as the character keys. So in that case, if you're really sure that some of the key events should not be translated by the hardware key engine, then you should just forward the key event instead of sending it. And we can just send the commit string. We have seen what is the commit string. But you might just find, in some cases, sending key event, forward key event, sending commit string, they all have the exactly same behavior, but actually it is different. I just explained the send key event and the forward key event is different. And when you just send the commit string, well, if the string itself is within the ASCII code range, I mean, if you're just sending a string with a single character and the character itself is within the ASCII code range, it would be better to just send by the send key event or the forward key event, because commit string does not generate any kind of key event. So there could be some of the legacy applications, like web application, they just rely on those kind of key events to recognize which key was pressed. So in that case, the application will not just work normally. So it is recommended to use the send key event or the forward key events instead of send it as a commit string. And also, we can just update the pre-edit string. We can just show it and then hide it. And we can just control the appearance of the pre-edit string. Some part will be just highlighted, some part will be just underlined, and we can just change the foreground color or the background color of it. And within the pre-edit string, there are cases that there is a cursor. You can just move the cursor inside the pre-edit string, so you can update the cursor using the update pre-edit caret function there. And also there are some of the functions that we can just deal with the candidate window. We can just update the content of the candidate window, and we can show it, hide it, and expand it, contract it. And we can set a candidate window style. The first line just shows some of the example. The candidate window should be one-lined, two-lined, or it is a fixed style or the floating style, meaning whether the candidate window should be displayed right above the software keyboard, or it should be just displayed right below the pre-edit string, something like that. And more, yeah. There are more APIs, but I just picked some of the important APIs. There are just, some of them are already just provided in other platforms, but we have been just focusing on implementing those kind of software keyboard engine related interactions. But the thing here is that we are still incorporating the features of core APIs. Well, there are some of the features that exist in core API, but not really found in the native APIs. So in the case, if you're just really doing something and you cannot really just find some of the specific feature in native APIs, in that case, don't be disappointed. Just check out the core API header files first, and if you can just find those kind of features in the core API header files, soon it'll be just included in the native framework also. So if you just really need it, well, send us your feedback, use the mailing list or whatever. So we're always wanting for your feedbacks about this. Okay, I think that's all I have prepared for today. So if you have any kind of questions, you can find the microphone on the floor. So ask me questions, and I think that's it. Thank you.
Thank you for the presentation.
Okay.
Do you have a capability to connect with the dictionary and provide correction or suggestion for the keyboard?
You mean the predictive text, right?
That's right.
Well, so are you just talking about a hardware keyboard or keyboard engine or a software keyboard engine?
Okay.
Well,
well, either way.
Okay. Well, it's solely up to the software keyboard engine developer. Actually, in the platform side, we don't have any kind of dictionary or suggestion module for that. So okay. Usually when we just make a mobile phone, then we just have a contract with those kind of a company that has those kind of solutions. Yeah. So it's up to the developer.
You know, there is an iBoss in the desktop Linux distribution.
Okay.
Most Linux distribution has selected iBoss instead of SCIM.
Right.
So I want to know why Tizen selected SCIM instead of iBoss.
Yeah, we already just aware of the iBoss is also wonderful framework for handling text inputs. But actually, at the time, we have just investigated, before we just start the input service framework, at the time, we investigated all those kind of different input-related frameworks. At that time, iBoss was not really mature, well, because iBoss was started later than the SCIM, right? So at that time, SCIM was better in terms of stability and all those kind of support. But recently, the iBoss has taken the place of SCIM in many Linux distributions. So we are also just having our eyes on the iBoss, and somehow if there is any kind of benefits of using iBoss, maybe you can just consider it in the later versions also. Yeah.
So according to Tizen IBI 3.0 Wayland version, you know, Wayland.
Wayland?
Yeah. In Tizen IBI will be released with the Tizen IBI Wayland version. So I think SCIM, this ISF has many X11 dependent code.
Right.
So I think that will be problem in Tizen IBI.
But actually, so there was a conference scheduled for those kind of Wayland support last week, but the conference was canceled. So, but anyway, we are still working on the porting the ISF into the Wayland also. So, but nothing has just fixed yet. But anyway, we're still working on it.
Okay, thank you.
Thank you.
Some of the code you were showing was C-based and some was C++. Do you actually support both, or?
Well, the some of the code I just showed you today are the core APIs. So it is some kind of code that is internally used. So if you just make a software keyboard engine by yourself, if you just download the SDK, all those kind of native APIs are the ones you can use. So I just introduced some of the core APIs to just let you understand the general idea. Okay. So if you just write your software keyboard engine, then it'll be based on the C++. Okay. Anybody else? Okay, thank you for listening.